Thanks, and good morning, everybody. Hello, all the Zoomers out there. So, Hoop had asked me to talk about this. I've got two different reference sources to check your voltmeter, and these have been checked with equipment that are about $40,000 worth of Hewlett-Packard ideas, and I'll show you on the video what these look like here in a minute. Okay. So I'm going to talk about multimeter usage in ham radio and what are some useful tasks that we can use a multimeter for. Well, a multimeter is probably one of the first pieces of test equipment that you ought to have as a ham radio operator, and you can get them from $2 from Harbor Freight to $900 or $1,000 for Fluke or Hewlett-Packard meters and anywhere in between. So what are some tasks that you can use in your ham shack? Well, you could check to see the power supply voltage on the new power supply you just bought is proper. You could check to see if your handy-talkie battery is fully charged. We could measure the current drain on your radio to make sure that you're going to have enough battery power in an emergency situation in case the power was out and you had to rely on solar panels to charge your batteries, that sort of thing. You can check that bag of resistors that you bought at the flea market at the Huntsville Ham Fest to see how accurate the resistors are, make sure they're working properly. And if you have to find a resistor and you put a couple of resistors in parallel, you can see if it works out using the formula to change resistance versus putting them in series, if that works different as well. You can check to see if a fuse is blown. You can also troubleshoot your broken rig by checking the bias voltages compared to the service manual for your particular radio. Those AA batteries that your kids were using in their little video games and stuff, you can see if the ones they left you are still good or not, and if you have to throw them away. You make sure your coax is not shorted between the shield and the center connector. You could check the power level of the voltages in your ham shack to make sure you're getting true 120 RMS or 240 RMS. And we're going to talk about RMS reading versus average reading meters in a minute. You could also check for continuity between the ends of the TNC cable that you just soldered. So there's lots of things that you can do and use with a multimeter for in your ham shack and in ham radio. So what types of multimeters are there? Well, the earlier ones are the analog meters where you've got a dial and a needle that just moves back and forth. Those are older. I don't think you can even find an analog meter nowadays. Most of them are digital. And then the digital come in two different forms. They come in a digital form with manual ranging, where you have to set ohms, kilo ohms, mega ohms, millivolts, microvolts, regular volts, that sort of thing. Or you can have a digital with automatic ranging, like this Fluke 87 Roman numeral 5. And what are some of the multimeter functions that we can use when we measure with a multimeter? Well, you could check DC and AC voltage to make sure they're correct. You could check your current, both DC and AC current. You can check the frequency of the AC current. If you think you've got a 60 hertz current, is it 60 hertz? If you've got 100 hertz currents, is it 100 hertz? You could check the duty cycle of that AC current. So not all AC currents are sinusoidal. If they're sinusoidal, that's all neat and sweet. But sometimes if we've got stepper motors or if you've got electronic dimmer switches, you're not going to have a true sinusoidal curve. You're going to have a positive blip, a flat line, a negative blip, a flat line, and your duty cycle may be 30% or 40% rather than 50%. You can check resistance. You can check continuity, and the continuity is probably one of the more important things that we use our multimeters for, because it's real easy to check and see if you've got a short. You want to make sure that you've got connectivity between two pieces of wire. When there is connectivity, you don't even have to look at the meter, you can hear it. And some other typical meter functions are capacitance. You can also check inductance. You can use it to check diode bias and diode voltages to make sure that your diode is working properly. And then true RMS versus average RMS. Now this is kind of important because some of the meters are true RMS measuring meters, and when they are true RMS measuring meters, they're going to say true RMS across the top. If they're an averaging meter, you're going to read a different voltage. And Andy has an averaging meter, and the averaging meters tend to read about 11% higher in terms of voltages if it's anything other than a sinusoidal wave. So what is RMS voltage? And what do we mean? Well, when we take a look at the power formula for DC voltages, remember it's easy as pie. P equals I times E. Power equals current times voltage. Well, with a DC voltage, like a battery, that's not a problem. You can just measure it. It has just one voltage. But with an AC voltage, the voltage is constantly changing. It's going all the way positive to the peak and all the way through zero down to the negative peak and coming back in a sinusoidal fashion. So how do we measure? What voltage do we use when we're calculating AC power? Remember, it's easy as pie. Power equals current times voltage. But what do we use? What do we plug in for E, for voltage? Well, we want to plug in true RMS. Now, what is true RMS? Well, if we look at a typical sine wave, if all we did was average all of the voltage here and then made this positive and average that all out, we're going to get an average reading which is a little bit different than RMS. And in fact, if we didn't average it out, but we added all these positive voltages together, all these negative voltages together, we get a voltage of 0, right? Now, the other thing that's important is that the higher or the more negative the voltage is, the further away from 0, more work is being done. So much more work is being done at this point in the AC cycle as compared to this point in the AC cycle. Does that make sense? And so the way we calculate that is by RMS voltage, root mean squared voltage. And what does that mean? Well, it says, first off, let's square every voltage along this area, and by squaring it, then we get rid of the negative problem, because a negative times a negative gives you a positive number. Then we're going to average those. We're going to take the mean of those squares, and then we're going to take the square root of those means. So that's where you get root mean squared. And it turns out the root mean square is about 0.707 the amount of the peak voltage. So if you measure the voltage in the AC line in your house and it reads an RMS of 120 volts, that's actually a peak voltage of about 169 volts. And if you go peak to peak, then that's a peak to peak voltage of nearly 338 volts. But we're measuring AC RMS of 120, even though peak to peak is 338 and peak is going to be 169. If you have an averaging meter, it's going to read about 11% high on these checking devices because this is putting out a non-sine wave signal. And so if you get a reading, this is putting out a voltage of 5 volts for AC. Andy's meter is an averaging meter, and it read 5.55, right? Which is exactly what you'd expect from an averaging meter. If you have an averaging meter, it will not say true RMS. If you have a true RMS meter, somewhere on the front of that meter, it's going to say true RMS. All right, so let's take a look at what this means.
What is true RMS and why is it important to us? There are two ways that meters can take readings. When they're taking an RMS measurement, what we're reading is we're actually reading the RMS value of a signal. And what the RMS relates to is if I take a 120 volt signal, AC, apply it to a resistor, and then I take a 120 volt DC battery, apply it to the same resistor, it'll heat that resistor to exactly the same temperature. If we use an average responding meter, what an average responding meter does is it takes the average of a signal, multiplies it by 1.111, and then displays the RMS. So it's actually average sensing RMS display. This was fine when we had a world of nothing but linear loads. Nowadays we have a lot of electronic loads such as drives and even simple lighting controls. So if we take a reading on a signal that is not a clean sine wave, that has some distortion in it, the average responding meter takes the average, multiplies it by the same 1.11, but because the signal has changed, this is now the wrong number and it's giving us the wrong RMS measurement. A true RMS meter actually does this conversion inside the meter and gives us the true RMS reading. So when we're working with any type of electronic load, it's important to have a true RMS meter, because if we look over at the oscilloscope, here I'm showing the voltage signal in red and the current signal in blue. Even just taking this dimmer switch, you notice how the signal gets distorted, but an important aspect is as it gets distorted, the peak gets higher. So what happens is you'll actually read a signal too low with an averaging RMS versus a true RMS. And this could cause you a lot of problems if you have a breaker that's popping intermittently and you measure it with an average responding meter, you're reading 13 amps on a 15 amp breaker, you say, okay, well that's not the problem. If you take a true RMS meter, you might read 18 amps on that 15 amp breaker, and then you're saying, gee, I wonder why it's not popping all the time. So in today's world of electronic loads, it's very important to have a true RMS multimeter or a true RMS clamp meter to get the correct reading on current.
All right. So a couple of other things. This is an excellent book that I'd recommend. It's Everything Electrical, How to Use All the Functions on Your Multimeter. It's about 15 to 20 bucks from Amazon. Excellent book, I'd recommend. And then after the second presentation, we'll start measuring your multimeters and we'll let you use our reference sources. Dave Matthews, KI4PSR, has one. I've got another reference source here. This is from DMM Check Plus. And like I said, these have been calibrated against $30,000 to $40,000 Hewlett-Packard and Siglin equipment, that sort of stuff. Any questions? All right, well, great. Thank you all very much.